Okay, so when the unstable nuclei undergo radioactive decay, undergo nila og radioactive decay, wherein a new configuration, no, matransform ang radioactive nga material into another configuration. So meaning there is asa man ang change ana sa nucleus sa atom. Now these changes in matter that originate in the nucleus of an atom are called nuclear reactions. So when it undergoes decay di ay kana siya nga reaction is called a nuclear reaction. These reactions involve changes of nuclei that result in changes in their atomic number, mass numbers, or energy states. And that's what happens in undergoing decay. So to describe a nuclear reaction, a balanced nuclear equation is used to reflect all the nuclides involved in the reaction. So just like good kung na kay redox nga equation, so napod kay redox nga reaction, so napod balanced nga equation nga mo represent sa reaction. So same rapod na diri. So na nuclear reaction, so napod balanced nga nuclear equation nga mo describe sa nahitabo nga reaction. But it's just this time, ang ma-reflect sa nuclear nga equation is all the nuclides involved in the reaction, but it includes their mass numbers and atomic numbers. Kaya diba kung mag-write lang ta og simple nga chemical equation, we don't include baya the mass number og ang atomic number. So this is special because ang changes man gud kay naa sa nucleus, unya dito nato makita sa iyang mass number. So the mass numbers, the atomic numbers, and the other particles involved in the reaction. And kani nga particle nga gisgutan diri kay kadto ning particle nga ma-release inig undergo niyang decay. And also for other reactions, not just decay. So nuclear reactions also follow the law of conservation and are balanced in two ways. So the sum of the mass numbers of the reactants and products must be equal on both sides, diba? Left side for the reactants and products, on the right side, and also the sum of the charges of the reactants and products must be equal. So nag-additional lang ta aning mass numbers niya. Kinahanglan mo equal. Now, inig-undergo niya atong decay, diba, nagisgutan diri particles involved in the reaction. So these are the particles involved in the reaction. Now the radiation given off in a radioactive decay may be in the form of, that's why, so kani radioactive decay siya kay mo release siyang radiation. Kadtong mga particles mo ni siya ang radiation. So these are the different radiation or particles involved in nuclear reactions. It could be an alpha particle, a beta particle, a positron, a proton, a neutron, or a gamma ray. So an alpha particle is a helium nuclei consisting of 2 protons and 2 neutrons. So mura lang helium. So you can use the symbol He for the alpha particle, or you can use the alpha symbol for the alpha particle. And then the beta particle are high energy electrons. So we use the symbol E, or we can use the beta nga symbol for the beta particle. A positron is a positive electron. So that's why it's positron, positive electron. They are particles with the same mass of an electron, but with 1 unit of positive charge. So instead of negative uncharged, positive na siya. Its mass is still 0. So mass maning ibabaw. So just like electron, 0. And then the proton, which is a nuclei of hydrogen atoms. So one atomic number of 1 and a mass number of 1. And then the neutron, which does not have a charge and a mass number of 1. Particles with a mass approximately equal to that of a proton, but it does not have a charge. So mommy and charge. This is the charge, this is the charge, and the charge. And the gamma ray, so we just use the symbol gamma. It's a very high energy electromagnetic radiation. So it's an electromagnetic radiation, no charge, no mass. So it's just a radiation. So let's talk about the different modes of decay nga kani nga mga particles kayo na involved. So the first type of decay is called an alpha decay. So by the way, these modes of decay, they're called according to the particle involved in the decay process. So the type of decay that a radionuclide undergoes is identified by the radiation emitted. So paggangan nga alpha decay, meaning alpha particle uninvolved. So when a particle undergoes alpha decay, there is an emission of an alpha particle from the nucleus. So hinumdumi nga ang alpha particle kay helium siya, iyang atomic number kay 2, iyang mass number kay 4. So meaning, kung mo-undergo siya alpha decay, so di ba hinumdumi kadtong inig decay niya ang parent nga nucleus, inig undergo niyag decay, mo produce siyag daughter nucleus plus particle. So in the case here, the particle is the helium. So kinahanglan man mabalance ang mass numbers o ang atomic numbers on both sides. So ang particle kay atomic ang mass number niya kay 4 man ug 2 man diri. So para ma-equal, so kaning mass number diri sa left sa parent nga nucleus minusan na tog 4. Nya yung atomic number minusan na tog 2. So ato jung tan-awon nga inig-add aning duha equal to this, equal sa tanang naa sa left, inig-add ani equal pud ka tanang naa sa left sa ubos. So dapat equal sila. So this is the parent nucleus, which is an unstable atom, and this is the daughter nucleus, and this is more stable lang compared to the parent nucleus. But again, this could still be unstable and could still undergo another type of decay. So this is an example of the alpha decay of uranium-238 producing a more stable thorium-234. So when uranium-238 undergoes decay, alpha decay, so again kaning alpha pwede na nito ilisan og helium, no? Pwede ra kaayo. So 238 kay 4 man ni siya, so 238 minus 4, so 234 nya 92 minus 2, 90. So inig undergo din ni uranium 238 og alpha decay, dili pasabot nga uranium ang ni-undergo og decay, nga uranium gihapon ang daughter nucleus kay kanang may change sa iyang nucleus, no? Ig-emit niya ani nga particle mo minusan naman to, so mo produce siya og isotope sa thorium, so thorium-234. Next type of decay is beta decay, so meaning it will involve a beta particle. So the emission of a beta particle from an unstable atomic nuclei. So this will happen if there is an excess number of neutrons. Kung naay sobra nga neutrons. Ang beta particle kay electron ba yan, no? So when a beta particle is emitted, a neutron is converted into a proton. Kaya daghan raman ang neutron. So ma-convert siya into a proton. So in a beta decay, therefore, there is no change in the mass number, kay 0 man ang massa sa electron, but there is an increase by 1 sa iyang atomic number, kay ang neutron ma-convert to proton. Or, we can just look at it from the equation. Nga kung kani siya, A, nya 0 ni, meaning this is still A. Nya, kung kani kay Z, unya negative 1 ni siya, so pila man ni, plus 1 ni siya. So, ato siyang tanawon nga Z plus 1 minus 1 is still equal to Z. So, in beta decay, there are more neutrons. So, when a beta particle is emitted, a neutron is converted into a proton. So, this is an example of carbon-14 undergoing beta decay, producing a more stable nitrogen-14. So, 14 gihapon, pero naplasan nag 1. So, nitrogen-14 is more stable compared to carbon-14. So, these are isotopes of carbon and nitrogen. And then we have the gamma radiation. So, gamma radiation is a penetrating electromagnetic radiation arising from the radioactive decay of an atomic nuclei from an excited state to its ground state. So, they are usually emitted after an alpha or beta decay. So, inig undergo niya og beta decay, it is still in the excited state. So, mo-release siya gamma para ma-unexcited na siya to its ground state. Gamma rays do not have mass and charge. Hence, when a nuclide undergoes gamma decay, there is no change in its mass and atomic number. And because of this, kaya what might change sa iyang atomic number, usually, ordinarily, dili siya i-appeal sa pag-write nuclear equations. Because of this, it is ordinarily omitted in writing nuclear equations. So, kadtong ganiha, kadto si uranium-238 nga i-produce niya thorium-234, after atong alpha decay niya, mo release pa to siya gamma. So, excited state pa man siya. So, i-release niya gamma nga radiation, ma-de-excite siya. So, this is now in the ground state. It's not an excited state anymore. No? It becomes unexcited. And then, after the gamma radiation, so we have the positron emission. Positron is a positive electron. It's the decay which involves the emission of a particle that is identical to an electron, but with a charge of +1 instead of -1. So again, this is the positron. This mode of decay is characteristic of radionuclides that have many protons for stability. So, di ba, ang beta, mahitabo siya kung daghan og neutron. So, baliktad ni si positron, mas daghan po ni siya og proton. So, in effect, kay mas daghan man siya proton, si proton, inig-undergo ni ang particle, inig-undergo niya positron emission, si proton, ma-convert siya into a neutron, thereby increasing the atomic number by 1. So, baliktad, di ba? Kay ganiha, ang daghan neutrons, ma-convert siya ang neutron into a proton, inig-undergo niyang beta decay. From positron emission, mas daghan proton, so kay mas daghan mag-proton, ang proton, ma-convert into neutron. So, because of positron, di ba, iyang mass kay 0, and iyang charge kay +1, so, the mass number remains the same, but there is a decrease by 1 in the atomic number of the muna siya sa daughter nucleus. So this is an example of the positron emission of copper-64 producing a more stable nickel-64. So si copper, atomic number 29, 64, and then, kay pwede ra sad actually nga ibutang nato diri. You can use a beta nga symbol for the positron. Nya, diba? 0 ni siya diri sa ibabaw, +1 ang iyang charge. So, kay 0 man siya sa ibabaw, so meaning, diri spika, 64 gihapon ni siya. No? So, ma-predict actually nato kung unsa iyang daughter nucleus. 29 man ni, so -1. This is 28. Nya, pwede din ninyo tanawon sa periodic table. Unsa may element nga number 28? Nickel di ay, nickel-64 di ay ang daughter nucleus. Mas stable din na siya ni copper-64. So, that's the equation nga ni-represent nga decay. So, that was positron emission. And then, we have K electron capture. So, the K electron capture is the decay in which an electron in the innermost energy level, pinakaduol sa, of course, ang iyang i-capture, ang kadto yung pinakaduol niya, no? So, electron in the innermost energy level falls into the nucleus. Because the electron is consumed rather than formed in the process, kay capture man, so dili man siya ma-release, so ibutang nato siya sa reactant na side, sa left side. So, it is shown in the reactant side of the reaction. It is more common with heavy nuclei, and just like positron emission, has the effect of converting a proton to a neutron. So, ato lang, nga ibutang siya diri sa left side because gi-capture man siya. So, kung muna siya ang atom, na diri ang electron, mo fall na siya into the nucleus. I-capture siya sa nucleus. So, this is an example of the K electron capture. So, you can actually just not include K. You can just say electron capture, but you already understand ganong na siya K diha. So, the electron capture of carbon-11 producing a more stable boron-11. So, carbon has an atomic number of 6, and when an electron is captured, so boron, the mass number of boron is still 11. 6 minus 1, we have 5. So, boron is the daughter nucleus when carbon-11 captures an electron from the innermost energy level. So this is a summary of all the type of the different modes of decay and the nuclear equation representing them and the changes in their mass and the atomic numbers.